Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
Hello and welcome to another episode of the Web Platform Podcast, episode number 159. Today we're talking about lithtml. We are your hosts this week, Justin Ribeiro, Amal Hussein, Leon Revel. Hello, wonderful people.
Hi, everyone.
Hey.
And before we introduce our guest this week and talk about all things massively awesome that's coming with lithtml, I'm going to throw it over to Leon this week, who's going to talk about This Week in the Web in 2 minutes or less. Leon.
Thank you, Justin. I've got loads of new stuff this week. So first of all, Parcel version 1.7 has just been released, which has got tons of new features and improvements, including out-of-the-box support for Vue.js. TypeScript 2.8 has just been released, which comes with loads of new features, including conditional types, which allows you to choose types based on other types. A release candidate for RxJS 6 has just been made available on GitHub. Firefox has just announced Firefox Reality, a browser for VR and AR content. And Google has just published a JavaScript style guide. And if you want to learn more about building animated user interfaces with the Web Animations API, then you should check out my new Pluralsight course, Building UIs with the Web Animations API. And that's everything from me for This Week in Web.
Some fantastic news from on the web platform this week, Leon. But speaking of magical, interesting things on the platform, this week we've got a fantastic guest. Justin Fagnani is here with us to talk about lithtml. Justin, thank you for coming on the show.
Thank you for having me. Hello, everyone.
So for folks out there who don't know you, tell everyone a little bit about yourself.
So my name is Justin Fagnani. I've been at Google for almost 10 years now. And in most of my time at Google, I've been working on kind of developer-focused products. I started the App Maker project at Google that kind of launched a year or two ago, and then I joined the Dart team to work on developer tooling for that. And then most recently, for the last few years, I've been on the Polymer team, and mostly heading up the tooling team of Polymer, so working on the Polymer CLI and all that. And so my foray into lithtml is a little bit of a change to from the tooling side into the kind of client side.
So how does one decide to get into tooling? Tooling seems like one of those very specific things that developers want, but are also terribly fearful of to get into themselves. How did you get started in just the general notion of tooling?
I think it actually comes from being annoyed. You're a developer and you use lots of tools, and tools are hard to make, so there's always something they don't do or don't do right, and you kind of get annoyed by them, and then eventually you start fixing them. And I think if you follow that thread long enough, you're like, well, why don't I just make a whole new tool that does things the way I want? That kind of started when I came to Google. Before Google, actually, I had spent some time as a FileMaker contractor, and I got, had my wish list of things I wanted it to do. So when I got to Google in my 20% time, I started a FileMaker kind of competitor. And I think with tooling, it's kind of been like that too, that we've had a lot of frustrations and we want to solve them. And so we write tools to do it. And Polymer is in a unique situation too, or at least it has been, because Polymer has used some very unique technologies like web components and HTML imports. And so for a lot of Polymer's life, it's had to create its own tools because other tools didn't handle those formats. So I took over the tools team in Polymer at a point where we realized we really needed to invest in tooling to make the developer experience great, because it wasn't being made great yet by the other tools out there.
The tooling definitely has come a long way. I mean, as someone who uses that tooling literally every day, the quality of tooling really makes the experience as a developer quite nice. I think it's an unsung sort of part of engineering that sort of goes often sort of overlooked. Because again, these are the things we use, and oftentimes we're frustrated about them, but there are actual people behind the code. They're trying to make our lives better, and we appreciate it.
Thanks.
So, sans tooling, I mean, lithtml.
Yeah. So, I mean, lithtml kind of has a similar story from my personal interest in it, is that, there were some frustrations and some itches to scratch, and we kind of followed them and led to something that we thought was really good.
So, could you describe in a little bit of detail for those who haven't actually heard anything about lithtml yet? Could you describe what it is, and just can you tell us a bit of the story about kind of why it was created, where it came from?
Yeah. So lithtml it's a very small library for writing HTML templates in JavaScript, and then rendering them and updating them really efficiently to DOM. And so the library is based around kind of two key features. One is JavaScript tag template literals, which are my personal unsung hero of ES6. I think they're amazing, and they really enable what HTML does. So those are these backtick delimited strings that you'll see in ES6 that can have expressions inside of them. So we use this to define a template, and then it uses the HTML template element kind of underneath in order to create templates that we can efficiently clone to create DOM. And so it's a library that basically takes care of some mechanics of taking a string, making a template out of it, going through that template and kind of marking and remembering where the dynamic parts, where the expressions kind of associate to DOM nodes. And then when you want to create instances from that template, it clones the template. It goes and finds those interesting parts, those expressions, and fills them in with the values from the expressions in your template literal. It's pretty simple. It's a pretty simple idea, but because of that, it ends up being relatively easy to implement and very efficient and very small. And so we unveiled this at the Polymer Summit last year, and it's gotten a really great reception since then. In terms of why we created it, I think if you all know Polymer kind of current events, the big news at the summit last year was that Polymer was moving away from Bower and HTML imports as its kind of packaging format, and to HTML and ES6 modules. And in that move to ES6 modules, we had to take templates from an HTML file where they're kind of written in native HTML into a JavaScript file where we had to put them inside of a string in inline. So we had HTML embedded inside of JavaScript. And this is really only a small change, but it kind of highlights some friction in between HTML and JavaScript here, in that you had this JavaScript container, a JavaScript module, and it had JavaScript and expressions all over it. And then inside of that, you had the string, which had HTML in it. And then inside of that HTML, you had expressions, which had their own JavaScript-like kind of syntax and behavior. And we were already using template literals because we wanted multi-line strings. And so it was really, really natural to us to want to use template literal expressions instead of Polymer expressions. This would be easier on us. We wouldn't have to maintain an expression parser and evaluator. It should be easier on users because they don't have to learn like a second similar but different expression syntax. It would be less code to ship to the browser and all that. So we started exploring that. We kind of had this brainstorming session about, how can we use template literals? And out of that, we kind of came and prototyped an initial version, which wasn't even called lit.html. It was called Polymer tags or something like that. And all it did was act as a front end to Polymer templates. So you would write the template in JavaScript, but behind the scenes, it would just create a regular Polymer template and then kind of glue together the expressions. And that worked. And so it showed us that we had something we could do, but it wasn't quite as all encompassing or powerful as lit.html.
All right. So, Justin, that was a really great introduction. Thank you. One of the things I really like about Lit, which is, that you get the full power of JavaScript, mixed in with your HTML. And this is not new for people using React and, Hyper HTML and other similar things. But with Lit, the really cool part is that, you're not using, you're using basically primitives that are native to the platform and, JavaScript, the language. And so that being said, are there, there's the push for using the platform when leveraging kind of DOM dipping and whatnot. Is there any, are there any exciting things that you're doing to I don't know, potentially optimize and push the spec a little further? Or I'm curious, like if the spec itself is growing and if you're kind of contributing back to the platform.
Yes, absolutely. I mean, if I can talk to the first point a little bit, like this is one of the best things about Lit and about JSX too, and other techniques like that, is that, we want to kind of expose the full power of JavaScript, or not even expose it, just like not get in the way of it. I've described kind of templating as a bridge between HTML and JavaScript, and there's kind of two ways to go about it. One is you pull from JavaScript into HTML if you have kind of custom syntax in HTML to have for expressions. And in that case, that you're writing templates in HTML, and you have this kind of impedance mismatch where your expressions are custom. They're not JavaScript, they're in HTML. And the other way is to kind of push values from JavaScript into HTML from the JavaScript side with native JavaScript expressions. And this is what Lit does. And we really like this because your data lives in JavaScript. And so all your data manipulation that you want to do is in JavaScript. So it's much more natural to manipulate that data, to transform it in such a way that it's ready for your view, and to do that all in JavaScript. And then you don't have to learn, like I said, the second syntax. So that's one thing that's really, really beneficial about doing it this way. In terms of the standards, so Lit actually, in a way, kind of was inspired both by Polymer moving to modules and by discussion on standards that had been going on since early last year. So in the kind of web apps working group, myself and a WebKit developer, Ryosuke Niwa, had been talking in an issue about how to bring some kind of expression capability to the HTML template element. And in that brainstorming, we had talked about this idea of, a lot of the basics that every template system has to do is like identify the dynamic parts of a template, both in the template definition, and then go find them again later once they clone that template. And we were talking about what the platform could do to help that. At the same time, people in Chrome who I was talking to had pointed me towards things like E4X, which is the XML syntax in JavaScript. And E4H was like a simplified variant of that done by Ian Hixie. And so there has been kind of an appetite that was, around back with these other proposals, and kind of was continued by Facebook with JSX for embedding markup directly into JavaScript. And so the kind of broad idea was that maybe we could glue these two things together, and the web platform could have a way of expressing where expressions are in a template and helping you really efficiently clone them. And then JavaScript could have a way of embedding markup into JavaScript, and you could use that markup to define this, parameterized template. So that's definitely the utopian vision for where all of this could go. The JavaScript side, I think, is a little more complicated to get going because, there are reasons why these proposals have kind of advanced to a point and then stalled out. But on the HTML side, it's looking very promising. There's this proposal from Apple called template instantiation, and it basically involves a way to describe in a template where the expressions are. It doesn't necessarily say anything about what type of expressions they are. Like, it doesn't hinge on defining an expression syntax itself, just kind of marking special places in a template. And so that's progressing forward. We have a proposal from Apple. We just got together in Tokyo earlier this month to talk about that proposal. And so I think we're going to see movement on that this year.
That's super exciting, by the way. And the reason why I asked that question is because it seems like there's a lot of synergy there. That's potential synergy, I should say, with the platform and rendering engines and, optimization and how we kind of do that. So I'm really glad to hear there's progress on that.
Yeah, I think because Lit was created with that in mind, so we have a member of our team who's been making a polyfill of template instantiation, and he made a version of Lit HTML on top of that polyfill, and I think it's like 120, 150 lines of code or so. So by building in kind of the low level primitives that all template systems need, I think we're going to kind of unlock a lot of template systems, becoming much simpler and faster this way.
Yeah, I find that really exciting. I think, this kind of thing is something we do with many different frameworks and obviously many different libraries, especially built around web components and things. So having a standard way to achieve these things is going to be really, really useful. So you mentioned that, the kind of the ambition for and the desire, the idea of lithtml came from, or partly from, Polymer moving to ES6 and ES6 modules. But lithtml is a separate library to Polymer. Is that correct?
Yes. Yeah.
Yeah. Could you just talk briefly about why you chose to do it that way? Why not just bake this into Polymer?
So, like I mentioned, the initial prototype of lithtml was based on Polymer. But at a certain point, we realized we didn't need a lot of the capabilities that the Polymer template system had, especially around two-way data binding. So one of the things when you're using JavaScript expressions is that the template system can't see the text of the expression. It can only get the value that's the result of the expression. And so you can't really implement two-way data binding because you don't know what property to write to if the property you're binding to has changed. So all the mechanism for doing two-way data binding would have gone unused. So it seemed easier just to rewrite the parts of the Polymer template system that created the template itself and end up with a very small library. And once you do that, you realize you can you don't have to use this library with Polymer. You don't even have to use it with web components. You can just define a template and render it to some place in the page. So I think the main reason we didn't necessarily integrate it with Polymer is that there was no advantage to it, and there was a lot of advantage to having a small library that people could use in all kinds of different contexts.
So speaking of small, I think I remember when I first heard your one of your talks at the Polymer Summit. I think it was like less than 2 kilobyte, like KB. Like, I guess is it still that small, like the entire library?
It's grown a little bit. I think it's coming in at under 2.5K right now, although we haven't, spent a lot of time since then, like trying to whittle down the size. So I wouldn't be surprised if we can get it a little smaller again. At some point, like it's small enough that, it's not necessarily worth it to shave off 10, 15 KB here or there, especially when we can maybe shave off like almost all of it if we get template instantiation.
Right. So I asked because I think one of the understated things about Lit for me is the extensibility. It's very agnostic, and it feels like it can kind of fit into a lot of different projects. Kind of almost like very similar to React and Backbone. Now you can have kind of refactor your app kind of bit by bit. It's very extensible and super cool in that respect.
Talking of React, obviously you talked about one of the ambitions for HTML is to obviously efficiently re-render templates, etc. And could you talk a little bit about how it compares to the virtual DOM or maybe even JSX in React?
Yeah, so I've compared it to JSX a bit before because it in some ways visually, if you look at it, lit templates look a lot like JSX. So they're similar in some ways and different in others. So I mean, one of the most obvious things is that JSX is not standard JavaScript, and it requires a compiler to compile to standard JavaScript. And lit HTML just uses template literals, so it is standard JavaScript. But in order to do that, lit HTML requires using this HTML tagged template literal to mark where your HTML starts and ends. But similarly, they're both kind of expression based in that like JSX is an expression; it returns to you a value, and a lit tag template literal is an expression. So they give you values, and because they're values, you can store them in variables. You can conditionally compute them, pass them around to functions, put them in arrays and stuff. And that means you end up having very similar patterns in JSX and lit. So if you have a list and you want to render, the data in that list, like each item, using a template for each item. The code ends up looking very, very similar in JSX and lit, in that you can just like take that array and do a map over it, and inside that map function return either JSX or lit HTML. So structurally, it's very, very similar, and it's actually quite easy to port from JSX to lit HTML by just wrapping your expressions in the backticks with HTML. Computationally, it's quite a bit different though, because JSX usually compiles to this series of create element calls, which will create a VDOM tree. And then the framework later will take the old VDOM tree and the new VDOM tree and kind of diff them. And in that compilation to create element calls, you kind of lose some critical information in the usual compilation of JSX. And that's knowing what parts of a template are static and will never change and what parts of a template are dynamic and come from expressions. Because in JSX, it usually all gets compiled to just the same kind of create element call. So when you do a VDOM diff, you have to diff nodes that may never ever change because they were just like static JSX. The difference in lit is that the unchangeable parts are in your template strings, and they're denoted by the backticks. So lit doesn't create a VDOM tree. Instead, what you get is kind of a tree of values. You get an array of literal parts that becomes your template, and then you get an array of values. And those values themselves can also be like a template result. That's the thing that the HTML returns. And so that template result can also contain an array of template strings and an array of values. So you get a tree, but it's a different type of tree. And it's a much smaller tree or a more sparse tree. And in this tree, you don't have to diff the static parts of your template. All you do is pass on the data to the render function for each template, and the render function just checks to see if the data changed or not. And it never diffs on the parts of the template that don't change. So, depending on how static versus dynamic your templates are, lit HTML can do quite a bit less work in determining what needs to update in the DOM.
So does that mean that lit HTML or that approach is just outright more performant than virtual DOM? Or is there some situations where the virtual DOM approach would actually be more efficient? Is there any kind of solid use cases for anything like that you could describe?
I think the benchmarking that I've done has shown that like if you have extremely dynamic templates, meaning that it's mostly expressions and not very much DOM in there, that VDOM can do very well in those situations because it's VDOM is not paying like a large per node overhead to do the diff. It's just sometimes diffing a lot of nodes. But when you get templates that have more DOM in them, then lit HTML starts doing better. But so far, it looks like in order to be faster than lit, you have to actually have like a very, very, very fast VDOM implementation. So the one that I think is currently beating lit on a few micro benchmarks that are highly dynamic would be like SnapDOM. And I think Salesforce makes SnapDOM. So they've actually talked to us about lit and making some common benchmarks and trying to trade ideas and make both SnapDOM and lit faster, which would be very cool.
That is super cool.
Yeah, love to see that kind of collaboration there. I think they're using VDOM type of stuff in the Salesforce library, but I think they want to look at how vendors can do things a number of different ways. So they're kind of curious about lit there.
Are all the benchmarks, etc., that you mentioned kind of available on GitHub or publicly somewhere? We could link it to show notes.
Not yet. I wish they were. I am working on a continuous benchmark runner in the lit repository so that we can track benchmark results like for every PR that comes in. Right now, there's a little bit of a backlog of PRs that implement new features that I've been a little hesitant to merge because I want to make sure that we hold the line on performance. So that stuff is coming soon. We've just been very busy trying to get Polymer 3 out the door.
Cool. Well, yeah, if you could share that with us when it is available, we'd love to share it around. Thank you.
Absolutely.
So you've been talking a lot about the creation and the markers that get added to the template strings. Can you elaborate on how two-way data binding works in lit HTML?
Well, lit HTML doesn't have two-way data binding. So the way it works is when lit lit doesn't see an expression. What it really sees when it builds a template is it just sees that there's two strings of the template with a hole in between them, and it doesn't know what the hole is. So what lit does is it fills in that hole with a little marker, and right now it uses a comment node, and then passes that to the HTML parser, and then it scans the result and it finds that comment node, and it says, okay, when I get a new value from JavaScript, I'm just going to replace the comment with that new value. And so for the values, all it ever sees is a value. It might see the result of an expression, like a string that says hello. And so, let's say you bound to an input tag, and you bound to the value property of that tag. Lit could potentially, have a way of knowing that it needs to listen to the changed event, but it wouldn't know what to do with that changed event. So in general, lit has this same structure that you would find in React and other unidirectional data flow libraries, is that you're supposed to pass the data down from above and let it flow down your DOM tree. And then when you want to respond to data changing to user events and stuff, you just fire or collect and transform events and fire them back up the tree. And then somewhere up the tree, you know how to handle that event. So it's very popular to plug in Redux here and to turn events into actions or some other state management system like that. And this ends up working very well because lit can be very efficient about if you pass an entirely new data object at the top of your tree, it'll only change the leaf nodes where the data has changed.
And that's not much different than the general notion of props down, events up. Anyhow, I mean that's sort of been that's we've been talking about
the
that
same,
in Polymer land for a long time, right? I mean we've literally been trying to get people to understand this so that their life generally is better as a whole. And it works very well, right? Because again, you get a lot of perf out of that, right? You don't have necessarily a lot of the overhead that sort of earlier experiments may have had in regards to sort of the way binding worked.
Yeah, and it's very easy to reason about, right? You know that if something changes deep down in your tree, it's not going to magically change properties somewhere else in your tree. You have to actually say, this event causes this property change, and when I render, I know what I'm going to get. You can follow the data down, events up pattern in Polymer too. Yeah, you can go either way. But in lit, we're kind of forced to, encode that pattern. It's like the only way to do it.
Yeah, I really don't think that's problematic, at least as someone who's stuck to sort of that paradigm over the time and sort of taught that paradigm to others. It is, like you said, it's very easy for people to sort of understand, particularly when it comes to just a lot of the libraries that already exist out there, Redux being a really good example of that. But, when you start to talk about this notion of that template rendering where you've got this hole in the middle of things, this is actually a really powerful sort of thing, because not only can you pass just values and things into it, but you can pass all kinds of interesting things, right? You can pass iterables into that. You can pass promises into it and have it return things into it. Like, it's not just this static piece of data that flows down into it, right? A hole can really accept pretty much anything you can throw at it. Is that about right?
Yeah, this was one of the biggest realizations we had when working on it is, the first data type we allowed to fill in one of these parts was just a string. And then it occurred to us, well, we want to be able to do nested templates so you can, do a map over an array and that kind of thing. And so we had okay, well, if it's a template result, then do this, recurse and re-render the inner template result. And if it's a string, write it in there. And then we were like, well, there's a lot of cases in Polymer where you want to create some DOM by hand. A template's not a great way to do it, or you're getting it from some other library. So maybe you want to let a node go into this part, and it's very easy to handle a node. You just append it right in the part. And then we just kept going to all these other useful data types. So like you mentioned, promises. Lit handles that natively. If you put a promise as a value for an expression, Lit will render it when the promise resolves. And same with if you put an array, it natively just will repeat the array. and things like that. And then we added what we call directives. And directives are a really, really powerful addition to lit HTML, and they're pretty simple too. So directive is just basically the idea that for every expression you have, there's this part defined, and the part lets you set the value of the DOM at that part. An expression is just a special type of function that instead of passing the function as the value, it calls the function with the part. And then now the function can take complete control over what it does to that part. So we've added a few built-in directives. One of them is called until, and it expands on the promise capabilities so that it can render some content, and then later when the promise resolves, it resolves that new content. And another, like you mentioned, I think, is that we have async iterable support. So async iterables are a new primitive in JavaScript for kind of like a multi-shot promise. They're like asynchronous arrays kind of. And we have support via these two directives for continually updating a part as new values come in on the async iterable, or appending to a part, like if you want to build up a list over time. And so I think those are the main data types we support. String kind of content nodes, promises, async iterables, and nested templates. And then from there, you can add your own support via directives.
The directives look really interesting. I mean, could you build something such as like some kind of translation library that would swap out the different text strings with different languages based on settings and something? Is that something you could use a directive for, or have I got the wrong end of the stick?
You can certainly do that with directives. I mean, directives are really open-ended. You can do just about anything. You could implement your own form of two-way data binding with directives. You can have directives that are able to look up into global settings and change how they interpret values. So yeah, you could do internationalization that way. We have used directives for implementing like Boolean attributes so that they toggle on and off. I think I've seen directives for kind of custom handling of class lists and style attributes so that you can just kind of target specific properties in there. Directives really, really open up the door to lots of possibilities.
So Justin, what would be the best path, or I guess a path to doing or handling theming with lit components? I'm assuming it's probably a lot more straightforward than obviously web components or Polymer.
Well, actually, Polymer has a lot of built-in capabilities to help you handle theming. So Polymer has a way of kind of composing style objects together. For those who aren't familiar with Shadow DOM, Shadow DOM makes some parts of theming easier and some parts are harder. So if you have a shadow root, you can just put a style tag in it, and that just defines the styles for your component, and they don't leak out to components above you or below you. So lit works very well with that. It's a pattern you don't see in JSX so much, but in lit, if you were doing a template for a web component using a shadow root, you would just put a style tag in your lit template. And one thing that's really cool about that with native Shadow DOM is that you can start parameterizing your style sheet. So you could put a binding in your styles for different properties or different chunks of properties. You might not want to do that all over the place for performance reasons, but it gives you a hook, at least from JavaScript, this declarative hook from JavaScript into CSS. So one thing, we have a team at Google that's, working on building like our next generation of application templates and, best practices for components. And typically what you see with styling is that you'll have a style tag, or for theming, you'll have a style tag declared somewhere that defines some common styles. And you'll just, it'll be defined as a lit template, and you'll just pass that on to another lit template where you want to put it. So you have like one module containing a common style tag. It's imported by another component or a number of components, and then inlined into their templates. So that is one nice way of handling theming. Another nice thing about that is you can flow chunks of styles down your tree. So if you want to have an application where part of your screen is themed one way and part of the screen is themed the other way, you can just pass different chunks of styles down your tree and embed them into your shadow roots.
It's a whole new world, Justin. It's literally.
Yeah. Oh, and I didn't even mention. Oh, yeah. It's the possibilities are going to be great soon. I don't know if you guys have heard of CSS shadow parts and theme.
Yeah, I'm looking really forward to them. I've been playing with the polyfill, and and I know the Vaadin folks are actually using, I believe, part right now as part of their polyfill as some of their new components. So yeah, part and theme look pretty cool.
Yeah, that's going to solve that last problem of styling with Shadow DOM, which is, Shadow DOM creates this barrier, and it's great to have this strong barrier between components, but you don't always want that. Sometimes you want to put something through that barrier there, and part and theme give you exactly that. So that's really going to bring web component styling to the next level.
So what's the story with ES modules and lit HTML? I'm assuming there is no story because it's just JavaScript. Everything should just work. But how do you see modules coming into play within the library, and as well as people playing around with dynamic imports and things like that?
Well, modules come into play a little bit just because lit HTML is one of the few libraries out there that is only distributed as JavaScript modules. This is a little bit bleeding edge, but there's some good reasons for it. Mostly because a lot of browsers support modules right now. I mean, all of them do if you turn on the right flags. And lit heavily uses caching so that it doesn't do duplicate template preparation work when it sees a template the second time you render. And we want to make sure that there's only one canonical version of lit in a page because the module contains the cache. And JavaScript modules are great. If you load them multiple times, you actually only execute them once. There's only one version of that module. So what we decided to do is, really invest in module support in our tooling, and then publish lit HTML and Polymer 3 and all of our elements as JavaScript modules and only JavaScript modules to NPM, and then make it so that it's very seamless to compile those modules either on the fly in our dev server or in our build system for browsers that don't support that. And that means that there's we don't have to publish a UMD version plus a module version or multiple versions. We just know that the module version is the one version, and it will get compiled to the browser as needed. So most of lit doesn't have a lot to do with modules, but just the way we're distributing it is a little bit new.
That's super cool, Justin. Thank you. So what are you most excited about that's coming, that's on the feature roadmap for lit? If you could share a few of those things with us.
In some ways, I'm mostly excited about Polymer 3 being shipped, both because we have some nice integration between Polymer 3 and lit HTML, and because we've been so busy with Polymer 3, and this will give us some time to kind of finish up lit 1.0 and get it out the door. So yeah, we've been working hard on a few things to make lit kind of production ready in the type of apps that we use Polymer for. So we've added shady CSS integration recently, so you can do Shadow DOM polyfills. We have IE 11 support kind of in a PR, just waiting for some benchmark verification on it. And we have what we call static directive support. So what this means is that, sometimes you want to parameterize a template, you want to inject a little bit of content in an expression, but you want to write that directly to the template. You don't want to have an expression that changes the template instances as you stamp them out. Styling is a good use case for this. Sometimes you have styles where you might have a global, theme set. And when you stamp out, when you create your template, you want to use that global theme, but you don't actually change it over time. And so we have that coming along, and then we're going to change some of the exports around a little bit so that this particular flavor of lit that we call lit extended is going to be the default export now, or the main module. And once we do that, lit HTML is kind of ready to go out. We've created this integration with Polymer called lit element, and so when those go out together, I think both the existing NPM world that hasn't used Polymer yet and the Bower kind of existing Polymer user base are going to be able to incrementally add lit element and lit HTML to their projects. So I'm very excited about that.
Yeah, I am curious as to, because there's a lot of things that, in terms of future work just on the project itself. I mean, you've got things like higher order templates, things like when and guard. sort of in the planning stages of things. I mean, what has the reaction been so far to lit as people have started to test it and use it? I mean, I'm sure that reaction is going to go up quite a bit once Polymer 3 lands and people go, wow, I can use lit for a lot of other things. But have you seen a lot of reaction of like, we need more things lit to do? Or do you see people taking it and using it as is now and saying, this is kind of enough, like this suits most of my existing use case?
I mean, the reaction's been phenomenal. I think lit kind of hit a sweet spot of, simplicity and power. Yeah, and in terms of some of these other features you mentioned that I want to get to, there hasn't been, a ton of demand that I've seen for some of them, like guard and whatnot. Guard is like a directive that'll, make an expression like null safe. Like if it throws, it won't, mess up your template. Actually, that's not exactly true. If it throws, it won't mess up your template currently, but guard will make sure it doesn't re-render unnecessarily like an expression if you want to say like, I know it didn't change. Yeah, I think we probably need to see some bigger applications develop to see a need for some of these. But already I have a lot of people, hitting me up on Twitter saying, hey, we rewrote our entire startup's website in lit HTML. Or a lot of Polymer 3 users have, jumped in and started using lit element. So yeah, the reaction's been great. I mean, I think we'll see what people need as they go along. But one of the nice things about directives with lit is that they're so easy to write. They're just functions that I think a lot of people have, if they hit a need, they can just, address that need directly themselves. And that's another thing that's great about lit itself being simple and extensible.
Well, it is interesting to say that, in a world full of frameworks, things like lit sort of sit on the boundary of it's not really a framework, because a lot of people have the notion that Polymer itself is a framework too, and I've argued against this time and again.
It's really not.
It's really not. And I think there's a lot to be said for that now, particularly in the world that JS modules might bring us, because now all of a sudden you can start to use these things and piece together exactly what you need with as little overhead as that you need, that gives you a much more performant basis that's built on top of the platform itself, as opposed to let's build stuff that the platform doesn't necessarily do yet and we don't really quite know the performance implications of it. And I'm not saying frameworks do that. I'm just postulating that sometimes occurs and people say, look at the brand new thing I built, and then that thing doesn't scale past like, a list of 20. So, I mean, it's interesting to see the ecosystem move that way.
Yeah, I kind of intentionally kept lit very agnostic towards the framework question. I mean, it clearly is not a framework. It's just, the ability to render some DOM. But lit itself has no provisions in it for any kind of component model, whether that's web components or some other framework. And the idea is that, I want to make it, attractive for other frameworks to say like, oh, I have an idea about, how I want to make my component model or whatever, whether it's web components or not. And I obviously need some templating. And here's this, small, unopinionated off-the-shelf templating library I can just plug in. So that was definitely a goal. And that's why the web component integration is actually outside of the lit library itself.
I think it's a solid choice. I mean, again, I like that. I like things that are generally agnostic. I think a lot of developers sort of look that way these days, or at least the ones I speak with. In a land of where web performance has really taken a much larger stage these days, you have to be cognizant of what you're going to run in your browser and on your threads. Like, this is not one of those things that you can simply ignore.
You know what, Justin? I only run Backbone version 3.4.5, so I don't know what you're talking about, but...
That one specific version is the thing I standardized, and I will never leave.
I've kind of like drawn my line in the sand, so yeah. Anyways.
Well, at least you're not using MooTools and Smush.
Oh, gosh. Oh, no. Or, we're not allowed to talk about that topic.
We can have that. Hey, you don't want to have that argument? We can have that argument.
Yeah, no. I think we're on the same side of the argument.
We are,
Justin.
So that's fine. Not really an argument at that point, I guess.
Yeah, exactly.
That's the like, hey everyone, it was a joke
Right.
argument.
Nerds making jokes, guys. Watch out, it's gonna get ugly. Anyways, so speaking of like tooling and frameworks, one of the kind of big barriers to abstraction for a lot of newcomers, learning how to write, software for the first time on the front end, or back end developers transitioning to write front end code, is all of the tooling and infrastructure around, like, what, I just want to use React. Like, I have no idea like how to set up Babel or all these other things. I hear that question a lot, and tools like Create React App were created. That was like a very punny sentence. Were created for to kind of handle, to like abstract away a lot of that complexity, right? Like, all of the scripts are hidden away. It's just focus on writing your React application. We're going to worry about all of the tooling and how this thing gets rendered and deployed. And so, is the tooling? What's the tooling story with Lit? Is, I guess, my first question. And the second question is unit testing. Is there, how are people unit testing Lit?
Yeah, I'm so glad you asked the tooling question, because the tooling goal with Lit is to never have any tooling.
Yay!
I mean, it's just not scalable. It's not feasible for every JavaScript library out there to have its own CLI. As the maintainer of the Polymer CLI, like, I say that, right? And this has been a very frustrating kind of point for me, is that, it's been great that all these frameworks have invested in making these, nice experiences for developers. But in a sense, it's only furthered the silos that kind of exist, separating these frameworks and kind of getting in the way of interop there between them. So now you don't have to worry, just about like, well, if I have components from different frameworks in the same page, how do they interact? You also have to worry about, well, if I'm developing a system that has components from multiple frameworks, do I have to switch back and forth between multiple CLIs and multiple build systems to get them to work? So Lit is just a library, and I hope to see many other just a libraries out there who say, like, I'm writing, this is a standard JavaScript library, why does it need specific tooling? I could imagine some types of specific, optimizers that know how to recognize, Lit templates and minify them, but I hope we can make that stuff generic so it's not a Lit specific thing. And even in terms of the Polymer tooling, one thing I'm very excited about Polymer moving to NPM and JavaScript modules is I think we'll be able to, make it more obvious that the Polymer tooling is not so Polymer specific. It's mostly about being able to analyze a project and understand what files are in it and what the dependencies are, and then run them through, dev servers or build pipelines. And I think as we go to NPM, we'll be able to kind of, emphasize how much the Polymer tooling can work for generic projects.
Yeah, Justin, I couldn't. If I could high five with you right now, I would high five. So I'm giving you like a virtual high five from Boston, because really, I think the tooling, people have created beautiful and wonderful tools, right, to solve all kinds of problems, but it is absolutely a barrier to, I think, interop. It's a barrier to being able to easily consume and digest and be productive sometimes. And for me, the NPM kind of motto where, this is my module, here's how to consume it. And it's agnostic to, it assumes either that this is running on the server or this is running, on the client. And that's about it, is an approach I'd like to see more libraries take. So thank you.
Yeah, I hope we can kind of further this and get more more frameworks and more libraries just saying you can use any tooling that does X, and then lots of different tooling will do that thing X, whether it's bundling in a specific way or compilation for specific browsers or something, and then people will kind of get to choose their tooling and then choose their libraries. It's been kind of interesting. We've been looking for new ways to host samples for Polymer and Lit HTML now that we're on NPM. And there's a bunch of really interesting like online, code sample editors like Code Sandbox and CodePen and StackBlitz. And a lot of them have provisions for each individual framework. Like here, create an Angular project or a React project. And it's been really interesting kind of talking to them to try to get a Polymer project working and asking for very generic features and them going, well, how about we just create a Polymer template? And then us going, well, no, that's not actually what we want. We want a vanilla JavaScript template that the Polymer users can just use. And so I hope like if we continue kind of asking for that kind of thing, people realize like, oh, vanilla JavaScript like really is a thing that's like completely usable now and you can build great complex performant apps out of.
My time for a high five now.
High fives all around.
Generic HTML and JavaScript coming to a web browser near you,
It's the
I know. We just need to make it cool, I guess. But anyways.
What's old is new again. That's the general gist of, that's how I used to write everything. Oh, I'm so old now again. I feel it.
Yeah. It's we should just call it hipster JavaScript, right?
Artisanal, handcrafted
hipster
JavaScript.
web. I don't know.
Have you all seen vanillajs.com?
I love it. It's great.
Yeah, it is. It's brilliant. So for anybody out there who's listening that doesn't know vanillajs.com, go and check it out. It's basically a fake JavaScript framework like splash page, which sells vanilla JavaScript as if it was a framework, and you give it all the benefits. Like how many dependencies it has, and it's like 0, and it's hilarious but brilliant. Check it out. So
yeah, go ahead, Leon.
All I was going to say is one of the attractive things that of lit-html in my mind is that when you read the README, like to kind of learn about what it is and what it does, like the README in barely any lines basically describes how it works. Like that's how simple it is, and that's really, really cool.
Yeah, I mean that's kind of left over from it starting as an experiment in the README, mostly kind of describing like why are we doing this and how does it work, because it's not totally obvious all the time, how a template system works and why you should be interested in it. So we started that way. I think that might be a little, oriented towards the template system nerds like us. We actually created a new document site on GitHub Pages. So if you go to polymer.github.io/lit-html, you will get to a site that focus a little bit less on how it works and a little bit more on how to use it, and has more colorful code samples and whatnot.
That's pretty awesome. And so I will be remiss to ask if we didn't get a chance to ask you about unit testing. Yeah.
Oh, right. This is another great thing that comes out of Lit being, in a sense, is kind of idempotent. It like lends itself really natural to functional programming. So a Lit template, if I haven't clarified, it's hard without code right here. There's two ways to look at a Lit template. One is a tagged template literal with the HTML tag that has some expressions in it. But you can't actually reevaluate that tag over and over again to update your DOM unless you have some function that calls that tag and returns it. So usually what a Lit template is a function that takes some data and then returns a tag template literal. And once you do that, and it returns the same basic result every time you call the function with the same data. Once you define a template that way, it makes it very easy to test. You can say, I want to test that, calling my template function with this data returns a template result that includes that data and those parts. And if you wanted to further test, how that actually renders to the DOM, then you can just, create a test DOM container, render it there, and then do some assertions against that. So you can do testing at multiple levels. You can test, kind of very fine-grained about what Lit returns, or kind of more the integration between Lit and the browser.
That is super cool. So it's basically there's no special library. Well, I guess like if I wanted to like mock certain behaviors or stub certain behaviors that the library provides me, I can pretty much do it with any tool without a problem. Any existing JavaScript like tool, like for example Synon.
Yeah, I mean Lit is just a series of functions, really. And so if you can, get in there and replace the function you use. So, that's typically the HTML tag for the template literal and the render function. So you could mock out the render function and say, like, I want to assert that I got these types of templates when somebody tried to render me. You could do that kind of stuff very easily.
Okay, cool. But is there like a helper library that someone's already created to do all those things? Or is there something that comes with the library by default? Or is it kind of just do it yourself? It's super easy.
I think it's mostly unnecessary. I mean, it's like kind of like, how do I test a pure function in JavaScript? It's one of the easiest things to do. So lit is mostly geared around writing pure functions. So they're absolutely, testable by nature.
That was a wonderful answer, Justin. And another high five from me. It's easy to test.
More high fives.
Yeah, I test all my code like we're all supposed to in production on a Friday. That's the way you test things. That's the way I was taught properly to test things. I don't understand the general need for this.
My users complain when something breaks, right? It's a great feedback cycle.
Oh yeah, this is. Hey, you know what? That's what UAT is for.
Wait. Do you work for Google, Justin? Just kidding. Oh, burn.
Oh,
yeah. I didn't say Google search. There's lots of other. But anyways, ironically, one of the Justins here does work for Google. That's pretty ironic.
We're running up against time at this point as we sort of round out episode number 159 here. Justin, is there anything we have not particularly asked you that we should have asked you that you think we should know or that the listeners generally would be thrilled about?
I can't think of anything off the top of my head. I had a little list of things I wanted to talk about, and I think we got to everything. I definitely want to make sure people know where to go to check out lit.html and lit extended, the web component library with it. So that's about it.
We'll make sure those get into the show notes. If people want to reach out to you, where's the best place to reach you, Justin?
It seems like the best place these days where all the activity is Twitter, actually. So my handle there is Justin Fagnani, JustinFagnani. And so I'm pretty easy to reach there. And the GitHub issues for lit HTML and related libraries are another great way too.
Fantastic. Well, thank you so much for coming on the show today, Justin. It's been a pleasure having you.
Thank you, Justin, and Amal and Leon.
Amal, Leon, closing thoughts as we round out episode number 159?
No, this has been super fun. I had one kind of closing question around, like, if people wanted to get involved with contributing to the project, are there easy ways for them to do that?
Yeah, I mean, one of the nice things about the extensibility is that you can contribute directly to the project. We love to see issues and PRs. We've had actually some great community contribution already, including getting Edge to work and finding out how to get IE11 working and some performance stuff and code cleanup. But in addition to contributing directly to lit HTML, you can also write your own directives, or we have a way for you to kind of customize the syntax and write like a custom flavor of lit HTML. And we've had people write like an Angular flavor of lit. We've also had people do like Redux integrations and all kinds of stuff like that. So it's nice to really see like an ecosystem of libraries kind of independently come together. And if anybody does that, they can ping me, and I should probably put together like a awesome lit HTML page that lists all these libraries. But we're very, very excited about any contributions from anyone and any kind of like use of lit. It's all kind of coming together to create a new community.
That's awesome. It's been really great chatting about lit HTML. So thank you very much for coming on the show.
All right. Thank you. Okay. Bye, everyone.
And this has been episode number 159 of the Web Platform Podcast. Today, we've been talking about lit HTML and all the magical things you can indeed do with templates in the upcoming sort of vanilla JavaScript land that just might be coming to a browser near you. Tune in next week when we talk about more things web, where we discuss the platform and hopefully new and interesting ways to use it. We've been your hosts today, Justin, Amal, and Leon. Have a wonderful rest of your week.